Okay, let's get on with the today's work. We're gonna do 10.3, which is basically moment or torque. There's one and the same thing, moment or torque. Moment or torque is where you have, let's say that you had a rusted bolt, or you're trying to unscrew a screw that is tightened very tight, right? So you have a screw or a bolt, and you have your wrench. Right, so you have a point here, and you're going to ratchet that wrench, right? Or if you want to go on the bolt, and if you want to unscrew it, obviously you're going to go this way, right? Righty tighty, lefty loosey, right? So we're going to go to the left, lefty loosey. So we're going to go ahead and apply a force this way to this point, to this screw. Okay, so would it be harder to use a longer wrench or a shorter wrench?
Shorter.
Shorter wrench would be harder, correct? Okay. The longer the wrench, the easier it would be, right? Okay, so you're creating torque. You're torquing this, or you're creating moment, okay? So moment about this point, we'll call this point A. Moment about this point A, okay? So the moment, there really is no set criteria, which is positive, which is negative, okay? In other words, this would be counterclockwise because you're moving it the moment you're trying to move this counterclockwise, right? If you're tightening it, it would go down this way, and you're doing it clockwise, right? So really, it's up to you to set up when is what we're going to call positive, right? Because we can have forces acting this way. This would be a one force, or we could have another force acting this way against us, right? So one's going to be going clockwise, where the other one's going to be counterclockwise, okay? So you're going to have to sum all those up, the sum of the moments, right? You're going to add them up, okay? All right? So at this point, we're going to call the moment about point A, and the moment about point A is nothing more than the distance here times the force. So the moment, okay, is going to be equal to F1, the force, times D, the distance about the point. And in here, I'm going to call going this way, going counterclockwise, I'm going to call that positive because I decided to call it that way. Okay, so here we go. This is the moment. Now, let's look at this force. Okay, the force here is basically perpendicular 90 degrees to the axis, okay? Okay, which is fine, all right? What happens if my force is not like this, but it is at an angle like this, okay? Which one's gonna be creating more momentum? The one that looks like this, or the same force that looks like this?
The force that was at 90 degrees.
The force has 90 degrees, correct? Because at 90 degrees, you are not wasting anything, right? Every force that you're putting is going towards moving that, right? Okay, good. So if I had a force that was at an angle here, so this angle here, we'll call this theta, this angle right here, right? Not all this force is going to act to turning it this way, right? So in other words, the portion of this force that is actually acting at 90 degrees is going to be only this portion here. Okay, so that's the only portion that's actually trying to turn it, right? Because the other portion, which is going to look like this, the other portion, because this guy here is this guy plus this guy, right? This guy here is acting this way, right? The part of this force, when I go ahead and take this force and I call it two forces, this guy plus this guy, because the vector wise, if I add this vector to this vector, I'm going to end up with this vector, right? So this guy here does me no work, does no good for me for moment wise, right? Because it's acting this way towards the point. Does nothing for me. The only thing that that's any good for me is this guy right here. Okay. So if you look at this, this guy is going to be F1 times the cosine of theta. So this guy here is F1 cosine theta, okay? So it is the theta here, okay? So it's only the cosine portion of that F1 that is going to help you in trying to or loosen this bolt, okay? What happens if I put too much torque here?
Would it not move?
Not if I put too much full. What's the problem that can possibly happen? Logan.
It could break. I don't know.
Yeah, the bolt could break off, right? The bolt can actually just break off, right? And you don't want that to happen because now you got a real problem on yourself, right? Because now you got a broken bolt with the part of the screw still in there, right? Okay.
Mhm.
So how do you prevent over torquing a bolt?
You slowly increase how much you.
That's one.
Only tighten it to 2 grunts instead of 3. 3 is always too much.
3 is always too much. Okay. So you are reading off of what?
My mechanics manual.
Well, okay. What is the device that tells you how much torque you're putting on it? It's a torque wrench, right?
Torque.
It's a torque wrench, okay? So for those of you who do not know what a torque wrench is, it's a wrench that actually, as you're torquing it, it tells you how much torque that you're applying to the bolt, and you can actually set it so that you do not over torque it, okay? Because now you have to retap it, untap it, and it's a big mess, okay? All right, so there is a device called a torque wrench, okay, that prevents you from doing that, okay? Okay, so that is the moment. So let's see if we can go ahead and use this, and let's see if we can do example 10.5 together. Let's see if we can do 10.5 together. Okay, and 10.5, this is example 10.5. We have something looks like this, and we have the origin here, and you're torquing it across that. We want to look at that. And we are 50 newtons. This is 50 centimeters, okay? Centimeters, okay, versus Newton, right? And Newton is what? 1 Newton is a kilogram meter per second, right? So immediately you're thinking, okay, I have meters here and I have centimeters here. So there's got to be, you have to be careful here, okay? And then we have another one that is going, oh, this is not 50, it's 5 centimeters actually. And then I have a force that's acting this way. This is the same, another 50 newtons. And this here is going to be 2 centimeters. Okay, and then I have from here to here is 3 centimeters. and I have 100 Newton force here. Okay. And my angle here is 35 degrees from here, this angle here. This angle here is going to be 35 degrees. Okay, which means that what? What is this angle here going to be? Isn't that going to be 35 degrees also? So this is going to be 35. Wait a minute. No, this is not 35. This here is 35. This here is 35 degrees. Okay. So the moment, looks like everything's going this way. So I'm going to call this way positive. So I'm going to call counterclockwise positive here, since everything is going that way. So the first force is simple. It's 50 newtons times the 5 centimeters. So it's 50 newtons times how many meters is 50 centimeters? 5 centimeters? 0.05 meters, correct? The second one, okay, now I have a 35-degree angle here. So I'm going to have add 50 newtons times cosine 35 degrees, but it's going to acting at the distance is 7 centimeters, 0.07. Then I'm going to add the last guy, 100, again, cosine 35 degrees, and the entire length here is 10 centimeters, so it's going to be times 0.1 meter, right? And I would do that and add all that up. If I do that, I'm going to get 13.55 Newton meter, right? Newton meter, okay? So that's how it goes. It's pretty simple. It is so simple that I am not going to do the next one. I'm going to leave that to you guys, and we'll go from there.